Hey, good morning, Logic 1. Hope you are doing well. Today we're going to be talking about semicircles, arcs, and sectors. So go ahead, make sure that you have done your facts practice, make sure that you've done all your mental math warm-up and your problem solving, and then reach back into the recesses of your brain where we talked about circumference and diameter and radius of a circle, because today we're going to use that to find the semicircle, the perimeter of a semicircle, particularly in funky looking shapes. So let's talk about a semicircle. You know that a semicircle is half of a circle, and what that means is the length of a semicircle is half the circumference, which is half of the measurement around a full circle, and it still has the same radius. It still has a diameter, which is halfway in between, and it still has the same radius, same diameter. And so what we're going to use then for this perimeter of a semicircle, is the formula is pi times the diameter divided by 2. We know that the diameter is going to be 2 times the radius. So here, for example, if my radius was 5, then my diameter is the measurement across the whole length of the circle, and it's going to be a 10. So let's look at example 1 down here. It says find the perimeter of this figure. Dimensions are in meters. So the first thing we have to remember here is that we're trying to find the measurement around this unique shape, which is half of a semicircle attached to a rectangle. So if we can remember, so I'm going to try and draw it here. Ta-da! No, make do with what I can. Here we go, right? So we got 5, we got a 4 right here. We know that these are right angles because it's a rectangle, so the measurement here is going to be 4. We also know that the diameter here, the radius here is 5, which means that the diameter would be 10. So we're going to use that formula we did up above, which is going to be pi times the diameter, which is 10 divided by 2. And when you multiply pi by 10, you get 3.14 times 10 divided by 2, and it equals 15 and 7/10 meters. All right, let's go ahead and go to the next page. Move it on over like that. All right, so, hold on. I apologize. We are not done yet. Move that back. Pull this over. Do some of my magic. Sorry, guys. All right, so now let's finish up. So sorry, that is just the perimeter of that semicircle. We haven't even done the perimeter of this rectangle. So now we know that the length, since the diameter is 10, because it's 2 times the radius, that means that's going to be this length right here. So I'm going to go ahead and change a different pen. So the length of my diameter is 10, which means this side is also 10. So we need to add all the sides of my rectangle, which is going to be 2 times 4, because there are 2 sides of 4 and 2 sides of 10. When you add that to the 15 and 7/10 meter, you get 8 plus 20 plus 15 and 7/10, and that is 28 plus 15. I gotta stop right there, guys. I'm gonna change my different color pen. So here where I said 2 groups of 10, I need to go back and correct that, because in fact there's only 1 10, and that is right here. This right here was already used in the area of the perimeter of the semicircle, so we're not going to add that 10. My bad. So it's not this, it's actually plus 10. So now we have 18. And when you add 18 and 15 and 7/10, you get 33 and 7/10 meters. All right, let's do example 2. I'm going to go and clear that board. Let's do example 2. It says find the area of this figure. Dimensions are in meters. So we're going to draw it out again, because I am a firm believer in drawing when you're looking at these crazy looking shapes, because it just helps. All right, so we have the same radius. It's a radius of 5. Got a side length of 4. All right, here we go. So we're going to divide the figure into 2 parts, which is what we did in the first problem. And here we're going to do area 1 and area 2. So we are going to do the area, because we're finding the area. We're not finding perimeter. Now the area of a semicircle is going to be pi r squared divided by 2 because we're not finding the area of the whole circle, we're finding half of it, so we're going to divide by 2. So we know that the radius is 5, so we're going to multiply 3.14 times 5 squared, which is 25, and we're going to divide it by 2. And when you do that math, you get 39 and 25 hundredths meters squared, because we're talking about area, which means we're going to square our units. So that's this first area over here. We still not need to find the area of this rectangle. So we're going to do, we know that the diameter of this circle, I'm going to change my pen, the diameter is going to be twice the radius, which is 10. So to find the area of a rectangle, we're going to say area is equal to length times width. My length is going to be 4 meters. My width is going to be 10 meters. And we get a product of 40 meters. And now we're going to add the area of the first half circle to the area of that rectangle. When you add that together, you get an area of 79 and 25 hundredths meters squared. All right, let's look at example 3. It says find the area of the shaded sector of this circle. So notice we have a circle right here. I'll go ahead and clear this. And we have a chunk of it missing. So we want to find this area of this piece of the circle. I'm going to turn the page here. Actually, I'm going to draw it first. Got a circle like this. We have a radius of 6 centimeters. And we have 300 degrees of the circle. All right, let's turn that page. And bring this over and move this. I'm sure there's a fancier way of me doing this, but here we go. Okay, so it says the central angle of the shaded sector measures 60 degrees. Do you know here how we said that this angle, or the angle all around from here all the way around was 300? That means that this angle right here is going to be 60 degrees, right? So 60 degrees is 1/6 of a circle. 60 degrees out of 360 degrees represents 1/6. So the shaded area is 1/6 of a circle. So let's go back to that area of a circle is going to be pi r squared, but we're not going to divide it into 2. We're going to divide it into 6 because there are 6 pieces to this circle. When you divide, or when you multiply pi and times the radius is 6 centimeters, that's what it says right here, times 6 centimeters. You're going to divide by 6. And here, oh, gotta do 6 centimeters because it's squared, my bad. Even over here in Saxon, it shows that you can reduce. So we got a 6 here, we got a 6 here, and now we have 3.14 times 6, and you get 18 and 84 centimeters squared. All right, so let's go read a further down. Let's go ahead and do a little bit of reading about arcs. So we talked about arcs a while ago, and what an arc is it's part of a circumference of a circle. So if we look at a circle, I'm going to clear this. If we look at a circle, this really well drawn circle I know I'm going to draw. Yeah, look at that. So circumference measures all the way around a circle. So if I have points A, let's see here, and B here, an arc is a portion of that. So maybe I could talk about arc AB right here. That right here would be a minor arc. It is less than a semicircle, and we're going to write it as AB, and we're going to put a little swooshy thing on top of it. That's arc AB. Now there's another arc between points A and B, and it goes the opposite direction and encompasses point C. We would write this as ACB because it is a major arc. It is greater than the semicircle. So let's kind of pretend here. We can also measure arc in degrees. Don't forget that the measurement of a circle is 360 degrees. That's really important here. So the number of degrees in an arc equals the measure of the central angle of the arc. So let's pretend minor arc AB is 120 degrees. So if this right here is equal to 120 degrees, what is the measurement of major arc ACB? Well, it's going to be 360 degrees minus that minor arc of 120 degrees, and you're going to come up against, so I'm going to do my math here, 240. Let me do the right subtraction problem. So sorry, 240 degrees. All right, so let's go ahead and do an example 4. In this figure, the central angle AOC measures 70 degrees. What is the measure of major arc ADC? Well, we know that we are starting with 360 degrees. We know that we're measuring across or around the circle greater than a semicircle, which means we're going to leave out the central angle of this guy right here. We know that this is 70 degrees, so we're going to take that away from 360 degrees. We're going to get 290 degrees. Right, move this guy out. Oh, let me do a little bit of moving. Hold on. We'll bring this guy over, this guy, and we're going to clear the board. Yes. All right, so let's do example 5. It says a minor arc with a radius of 2 centered at the origin is drawn from the positive x-axis to the positive y-axis. What is the length of the arc? All right, so we have to go back then to finding the area of, back to this drawing up here. So if we look up here, we see that we have a radius of 2, which is right here because it's on the x-axis. We're drawing a circle around the origin. That's what it means when it's centered at the origin. The central angle is right here at 0, 0. And we're drawing a circle all the way around 0, 0. What is the length of this arc? Well, we know that a minor arc is less than 180 degrees because it's less than a semicircle. We also know that this arc right here is 1/4 of a circle. So we have 1/4 of a circle, and that's important. And that's 90 degrees because you have a circle, and that's 360 degrees. So if you divide 360 divided into 4, what do you get? You get 90 degrees. Right? So we know that this arc is 90 degrees. The length of the arc is 1/4 of the circumference. And if you remember, the circumference of a circle is measured in pi times diameter. But we're not going to divide it by 2 for a semicircle. In fact, we're going to divide it by 4 because we know we're talking about 4 parts of this circle. So let's go ahead and plug in what we have. We have 3.14 times the diameter. Well, the diameter is not 2, but it's 2 times the radius. 2 times 2. What just happened to my math? I don't know. 3.4 times the diameter, 3.14 times the diameter of 4, which is 2 times the radius, divided by 4. And here we can cancel this, we can cancel this, and we find that our answer is going to be 3.14 units, or whatever unit of measurement. All right, guys, that was a lot. There's a lot handled in there. I want you guys to do your lesson practice, and if you have any questions, bring them to the Zoom meeting we're going to have on Thursday. Okay, hope you guys are well. Looking forward to seeing you soon. Bye.